away for a while. Maybe Luke knows more about it. But we started a while ago. Now, how old is UQRUG? Probably 4 years old or something like that.
Yeah.
So just as a regular meetup to help each other solve issues, learn new things. And lately it's been a format of doing a short presentation and then getting into the collaborative problem solving, right?
Yeah.
So yeah, it's good for people to join and learn something new, but also yeah, ask questions. And even if you don't have questions, you can still get something out of it. Now, it is collaborative, so if you feel like presenting something about your work or a cool package that you've heard about, or your 5 best tips to use the language, or maybe how Python is different to R and what's good in one and what's bad in the other. Any really topic that's loosely related to R, feel free to let us know, and we can organize for you to present. We're really happy to get contributions from other people, and so it's not just our voice all the time. And yeah, that's what makes it fun, and it's such a big environment, the R ecosystem, that there's always something new to learn. And because I was kind of away for the 2 last years, what I wanted to do is have a quick overview of what happened in the 2 last years. Going through all the news about R in the 2 last years, there's a lot to it. So I kind of focused on base R, the big releases of R, and also the tidyverse. And even the tidyverse, I couldn't get to the end of it. So what I'll do now, oh yeah, we should probably record, hey, if you want to do a video of that afterwards.
That'd be good.
Do you want to do that?
Yep.
Oh, I can actually, yeah. Does it make a difference?
It's already recording automatically.
Cool. All right. Well, I've got one of those pretty dry scripts that I'm going to go through. Hopefully not too boring, but I've settled on about 20 little short things that I thought were interesting. There's big things as well as smaller things, right?
Feel free to close that chat. I'll keep an eye on the chat.
Okay, cool. Thank you, Luke. Close that, and I'll make this bigger.
Nah, see the other ones on the top left?
Yeah.
Yeah, go to the middle one.
And then
click your button that you clicked before in the top right.
Thank you.
And do the same for that one. You and Linux, I swear.
It's not even going. There we go. All right, we're good. I get so confused with the 2 Zooms on the 2 computers. Okay, so I'm going to start with the release of R 4.3, which was a while ago, but I went through it and I thought, well, that's interesting. There's I'll try not to take too much time but if you've got a question about that bit of code, something that doesn't make sense or that curious about, please stop me. But this one is about, the first one here is about the ggplot. That's not ggplot, that's ggplot. So the quantile plots that are part of base R that look like this. It's a statistical plot. They got a new argument about confidence level, or 2 arguments. I wish I had an option for confidence level to put it higher for myself when I present, especially. But if you want to draw a band that describes the confidence level around the points, around the ggplot, you can use now that confidence level, that extra argument here, and you can further customize it with the conf.args option argument. So here I'm doing something like customizing the colors. So if I execute this one with the 2 arguments, so I want the confidence level at 0.5, and I want to customize it with a color light blue and a border that's pink.
So is it a percentile, that 0.5? Like, is that saying that the confidence level is 50%?
Now you're asking too many questions.
Yes. What if you change it to just 1?
Yeah, so 1 will make it, well, let's have a look. Wider. There you go. Now, if you want to learn more about this one, of course, it's all described in the
But that makes it not percentage based, because if it was 100% confident, then the line would follow the dots almost perfectly, you'd assume.
Or if it's a confidence level where you want the distribution to fall in that space and you want to be 100% sure that it's going to fall in that space, it's going to get bigger for it to have more probability to fall in. But I guess that's
one more question. Does ggplot2 have confidence level?
There is something similar in, for example, when you do a smooth line or a trend line, you know, the smooth geometry.
Yeah.
By default, usually there's that gray area that goes around the line. You can also change, I think, the span. Oh no, the span will follow the data for the curve. But then there's something about, yeah, computing the confidence level and having more or less of that shaded area around. Yeah.
Okay, back in the box now.
Can you explain confidence level?
Okay, so here, that's where I'm a bit like, I won't be able to, okay, let's go to the to the description. So you're looking at those X and Y together and you want confidence level. So that's for the computation of a confidence band. So that's what you see in between the two lines. And the I'll go to, okay. All right, so if confidence level is given, that's the description here, confidence band for a function transforming the distribution of X, so our first vector of normally distributed values here, to fall into the distribution of Y, the second one here, is plotted based on this paper. Now, I'm very limited in my understanding of this, but just know that you have that extra option now in ggplot to also show a confidence level, which wasn't the case before our 4.3.
Confidence is another way to describe probability.
So yeah, if you increase that confidence, you'll have, you'll have a bigger range because it's more likely that it's going to fall in that range. Right. So that was the first one. Now moving on to number 2 here, that's about the pipe. So piping something into something. If you've used that syntax before, what I'm highlighting here is the pipe operator for R, and you can use that to pass something to the next step. So in the processing pipeline, right, we're passing the data frame seatbelts, SB, to the function subset. So we want to subset the data frame and only find the values or the rows where low is equal to 1. So what's changed in 4.3 is that you can also use now the placeholder, this underscore, to refer to what is being passed on. Now, the base R pipe is still a lot more limited to the Magritte R pipe. That's where the pipe started in R. There was a package called Magritte R, and it's got a lot more features, and people still rely on it, especially people using the tidyverse. But more and more with every release, the base R pipe is a little bit more flexible. But if you want to learn more about differences between the two, there's this article here that talks about the differences, in particular that placeholder thing, when you want to refer to whatever is passed. So if I execute this, you subset the data set, and then you refer to the data set again to extract the kilometers column and only grab the 5 first values, and you end up with this. Next one is about the subset function. So we just used it there. So subset takes a data frame and you use a condition to say, only give me those rows, right? And that's very similar to the filter in dplyr. Here, what has changed is very small difference. It's just about warnings. But if I run this, see how I got the operator wrong here. I used a single equal instead of a double equal, like I should have done, because I'm comparing 2 values. It gives me now a warning, which is, it's nice to see, sometimes it's only about a little change, like a bit more information that comes out of the function. It's telling me that it's ignoring this one. it still runs and it doesn't, as you can see, there's values that have 0 in the column for low. So you still don't get the result that you were expecting, but at least you get a warning to then fix your issue. The difference with dplyr is that if you do the same error in dplyr, with the filter function, you actually get an error. It actually stops you. So just something to be aware of. If you mess up your condition in subset, you only get a warning, you don't get an error. Another change in R4.3, very small one. When you convert to a date, you can use a numerical directly without setting an origin, without telling time started at that date. Remember that the origin by default for R is 1970, 1st of January. So for example, here we're finding the date 10,000 days after the origin, 1970. Before it would error and tell you, you have to provide an origin. So that might be a good thing, that might be a bad thing, just something to take note of. It's not that common that we transform a numeric into a date. Usually you provide a string that says year, month, and day. Then we move on to R4.4. Another small one, it's an extra option in the diff function when you compare two things, or rather when you get the lag between elements. So for example, you provide a vector, it's going to say the diff between 1 and 2 is this, the diff between 2 and 3 is this, etc., etc. So here I'm comparing two dates. By default, it returns, if I run this, it returns in the console the number of days, the time difference of roughly 9,000 days. That's the difference between now and the release of R1, version 1 in 2000. But if you provide this extra unit option, or units rather, you can convert it, for example, straight away to weeks, which might be handy.
So is that the same as what you did the other week with dated if in Excel?
Yeah, a little bit, yeah.
So what units can you use? Weeks, years, days?
So in diff, you can mostly go down in units, because then months gets a little bit iffy. Units.
When you say down in days, so by default,
Or smaller units,
so
sorry.
by default it's telling you days. So by smaller, you mean you can go weeks, months, years?
Oh, the other way,
Or
sorry.
you mean go down to
There you
hours, minutes, seconds?
So here it says weeks, I can also go hours. Time difference in hours, yeah. Because, yeah, I guess.
Seconds.
Yeah, you can, yeah, why not? But what I mean, oh, all right, sex. You have to write SENC.
Well, some of them are short and some of them are not.
There's the number of seconds since the release of 1.0.
Which was
2000, February 2000.
oh right, it's there.
Yes. Then a little bit of visualization again. In base plotting, you've got the contour plot. So for this volcano data set, you get, I believe, the what do you call them? Height lines or altitude lines around a volcano, but you can also do the variant field contour. So that's existed forever, which is, it looks really nice. I like the gradient there. And what's changed in 4.4 is that you can use key border to then assign whatever color you want in the key, which was not possible before. And of course, you can give it a color, but you can also turn it off and say key border equals NA. And I think it looks a bit nicer to present the gradient in the key on the right. And using the same example, moving on to how you can abbreviate hexadecimal colors now as well. You can use any color, you can use color names. I think there's 600 and something colors in R that have a name, but you can also use any color with a hexadecimal value like this one, AAFFAA for a light green. So I've changed that color here in the key. But if it's doubled up like this, you can use the shortened version AFA, and it's It's a very small detail, but somehow you don't really need that much definition in hexadecimal colors. If you're going to define your own color, you can go in bigger steps and only use one symbol that's going to get then doubled. So very small change, but it's also nice to see that RStudio follows with that and also highlights that color and shows you what color it corresponds to. This one might be a little bit more specialized in that the function source now allows you to do different things depending on the kind of error that you get in your script. So I've got a separate script here that's called toSource.r. It's got a print statement, then something that says if a condition stop whatever you're doing, and then another print statement. So the difference in R4.4 is that you get now an option that's called catch.aborts that you can set to false or true depending on if you want the execution to stop or not, if that kind of error pops up. So if I source the script here, execute that, you can see that only the first statement gets executed, and then there's the error and it stops there. But if I set catch abort to true, the second version here, you can see that it will keep going through my script and it will give me, it will give me the second statement at the end. Still in R4.4, there's a brand new function that's called sort by. If you have used dplyr before, there's the arrange function that allows you to sort your data frame. So that's the same, pretty much the same thing. Before you had to do something that was a little bit involved in R to, well, not intuitive, I guess, to sort a data frame. You have to use the order function to create an index and then reorder your data frame according to that. So that works, but it's not particularly ideal. You do end up with the highest number at the top here, and then you go down because I used a minus before to make it from highest to lowest. But now we have the alternative to use sort by. It's a lot more readable. I think it's a lot easier to understand the code here. You take your data frame, you sort by a specific column, drivers killed here, it's a bit grim, and then just look at the top 5, I don't know how many, top few lines. So you get exactly the same result here, but you don't have to use that more involved solution. So very similar to arrange in dplyr. And one that might be interested if you develop your own packages, if you create your own packages, your collection of functions that you put together to share with others. You've got a new function now called package to HTML, which allows you to, in one go, document all your functions in one HTML page. So if I execute this, I'm doing it on the dplyr package, which takes a little bit of time because there's a lot of functions in there. But what you end up with is in your files, you have a HTML file here. If I open this, you end up with a table of contents and the general information about your package at the top, and then every single one of the functions that are defined in this package rendered with all the examples and the nice syntax highlighting as well. So I thought that was quite nifty. I'm moving to just visualization, ggplot 2. I'm looking at version 3.4 and 3.5 here. There's a new line width aesthetic. There was a bit of confusion before in ggplot 2 when you use the size aesthetic because you would catch quite a few different things. It would be the size of points, but it would also be the width of a line. So it needed clarifying. And I'll show you an example of what it looked like before. Here we've got a graph of air quality. Each line is a different month, and the thickness of the line is the wind, the strength of the wind. But you get now a warning message that says that the size aesthetic for lines is deprecated. And they recommend to use line width instead. So that's what we do in the next example here. We replace with line width. And also it changes slightly in that it uses a better extrapolation of size. And you can tell the difference a bit better between the different widths of the lines. And now it's happy to deal with size and line width separately. So I made a graph here that's just for an example. It's a bit more, there's a bit more code here, but just to show you that you can combine size and line width. You've got line width for the wind.
I knew that was coming because it resized your window as well.
Oh yeah. Okay. So you've got here line width for the wind, just like we had before. So the width of the line changes according to the wind strength or speed. But you also have the size that changes according to the ozone levels. So that's for your points along the line. So it's a terrible graph, but it shows you that you can separate those two now.
It's really interesting that you have 3 legends.
Yeah.
I've never seen 3 legends before.
I could have removed the color is a bit superfluous here.
So the color is
Instruction.
showing the month.
Yeah.
Wind is then the width of the line. Oh, yeah, right. I've just never seen 3 legends in a
It's very messy.
chart before.
But yeah, we didn't really need the color, but anyway. You can use in ggplot2 the group aesthetic, which doesn't show on with the legend, but it will separate your data into groups, and then you get 1 line per month rather than everything linked together. If you didn't have that, you'd end up with this monstrosity. The famous com plot. That's when you forgot to group something. Yeah. Okay. I'm moving on to another customization in ggplot2, and I will share this script obviously on the website. You can use justification for your bars and columns, I assume, as well. So if you use 0, it's going to be left aligned. If you use 1, it's going to be right aligned. And the default will be 0.5, I assume. So this is your default look, where the label at the bottom is centered on your bar. But for various reasons, you might want to customize your plot to have the tick on the left of the bar. So here, 3 is on the left of the first bar. And if you go to 1, it's going to be aligned to the right. So that gives you a bit more power in customizing your bar charts and column charts. It's also new in 3.4. And then we move to 3.5 more recently, still in ggplot2. There were changes in the last few versions of R that made it possible to use gradients and patterns. It added a bunch of functions in R to play with visual, lots of visual things, including gradients and patterns. So I've got one example here where we're creating a pattern, or rather we're creating a gradient, a linear gradient, this one here. It's using the function linear gradient. This is coming from the grid package, and it's a gradient that goes from pink to purple, right? Now, because I've used the group equals true option here, when I create this plot that uses, as you can see here, the fill for my bar geometry, it's using that gradient. You can see the gradient going through the whole of the plot. It's not per bar that it goes through. It's behind the whole visualization. If you wanted to change that and apply the gradient to each bar, you could also go false when you define the gradient for the group option. And now it's the gradient applied individually to each rectangle. I think.
So pretty, man.
Thank you. Good choice of colors. Yeah, I think that's a nice one that also replaces the functionality of other packages that were developed to kind of fill that gap. But now with beta and changes in ggplot2, you can do all sorts of things with filling areas with a lot of different kinds of gradients and patterns, and have a bit of fun with customizing your visualizations.
So it's using a grid package.
Yeah,
function.
which comes with R by default. It's central to R for anything visual. It's not loaded by default, but it is installed by default. And there's going to be lots more functions in there. For example, instead of linear gradient, you can use what's the other one? Polar, no, circular. There's another word for that. Polar gradient? That doesn't exist. Circular. There's another word for it.
Oh, good. I'll take your word for it.
Okay. Radial, right? Maybe. Yeah. Now you've got a center and then it radiates around again. But
Yeah. Phew.
all right. I prefer the linear one. You can change angles and all that. There's lots of options in there. Actually, looking at the help page for linear gradient, you get to all the different functions there, including pattern and all the options. Now, one interesting one for the text and label geometries. There's lots of new options now. I've listed 3 arguments here. There's angle to rotate your labels. There's size unit. Well, let's have a look at it. I'll run this one so you can see it here. And I'll highlight the, again, a very weird plot, but it's just to show you what's possible. You've got an angle equals 45 here. I've rotated my labels in my geometry, label geometry, by 45 degrees. I've also changed the padding here using the margin function. And the new thing is that you can change the margin for things individually. So you can go left, right, top, and bottom. You can change all those values separately. And I even gave a negative value, which is why the rectangle is smaller than the label here. So negative value for the left margin. And the third thing here is about size units. Because in a geometry, the default is millimeters, and in the theme, the default is point when you change the size of your text. It was really hard to sync the size of your labels with the size of your font in the rest of your plot. So now they've added the size unit option here that allows you to give the same value in the geometry and in your theme. So in our plot, we've got exactly the same size for the text that's on the plot, the labels, as the rest of the plot, your ticks and your axis titles. So that's also quite handy. You don't need to do weird conversions to figure that out. And the last bit for ggplot2 is changes in the box plot and how they deal with outliers. So by default, if you visualize distributions with box plots, you have lots of points for your outliers. With this data set, it's really messy. There's a lot of points. Probably not interested in them. But you have the option to hide them with the argument outlier shape. If you set that to NA, you say that I don't want any symbol for my outliers. So you say outlier.shape equals NA. That hides them, but you can see that it still gives the space for the outliers, even though you don't need it. If you actually want to remove entirely your outliers, you can run it with the option outliers equals false, and then it uses all the space for your whiskers or your staple, whatever you call it. I guess the whisker is the full thing, but Stable is the n bit. And the last one I want to talk about is dplyr. Again, lots of changes in there. There was version 1.1 that was released in the last few years, followed by, followed by nothing else. I mean, minor versions maybe. But let's have a look at a couple of changes for dplyr. This first one here is about temporary grouping. So we've used in dplyr group by to operate on part of your data, group by, and then do an operation. For example, summarize per group. So historically, and you will always be able to do that, you go data frame, then group by something, and then summarize to find your summary. And you get, for example, the mean miles per gallon per number of gears, right? That's all good, that works well, but if you want to, you can now replace the group by step with an extra argument in summarize, that's called dot by, and do the same thing with a slight difference in result. Group by happens to order your data by the grouped variable, whereas if you use the dot by argument, you can see that the result is just a little bit different. It's 435 here. It's not in order for the gear, whereas the previous version went 345. So that's one difference. There might be a couple more, but know that you can make it slightly shorter. Yeah, another very important thing is that if you use dot by, you don't have any remaining grouping. The grouping doesn't stay afterwards. So it's a bit particular for summarize, because if you group by one variable and then summarize, you don't have any grouping left afterwards. But if you group by several variables and summarize, you shed a layer of grouping every time you summarize. With the dot by argument, you do not keep the grouping. It's always removed. So it retains the original order and removes all grouping when done. It's the two main differences, I think. In join, new function called join by in dplyr. So there's lots of join operations that you can use in dplyr to put two data frames together and match them on one single column, or on several columns actually. So for example, you've got a data set of band members, really small data set where you've got Mick, John, and Paul who play in the Stones and the Beatles, and you want to join it with band instruments because you've got data on John, Paul, and Keith who play guitar, bass, and guitar. So the two columns you want to join on are artist and name. It's the same kind of data. It's the first names of the people. So that's the two column names that you want to use. And this is what we used to do, or what we've always done, and we can still do if we want to. We say, do a left join. The left table is the main one. Join band members with band instruments too. And the columns that you want to join on, or to join by, are name and artist. But the preferred syntax now, which is a little bit more consistent with what we do in the rest of the tidyverse, is to use the join by function, and then you don't need to quote your column names. You can go name = artist, kind of like a condition. And that's also consistent with extra things that have been added to dplyr to this version. You can do all sorts of joins now, even like you can join two tables saying, find something that's bigger than this. So a different kind of condition or comparison like here, bigger than this, and grab the closest one and then join on that. So you can do joins with lagging, for example, if you're dealing with dates. You can go quite deep into all sorts of weird joining of tables. So yeah, remember that if you do joining, this is the new syntax that's preferred, using the join by function and not quoting the variable names. The last thing for dplyr here is about something that made it into dplyr 1, but then people started saying that actually that's a bit confusing, it's not consistent, and maybe we shouldn't do it. In dplyr 1, you could start summarizing with functions that don't return a single row. Usually when you summarize, you want a single row per group, right? For example, the mean of a group or the maximum of a group, blah, blah, blah. But you could, since dplyr 1, be a bit more flexible in that you use a function that returns several rows and you will put all that together in your final data frame. So for example, it's a silly, and there's a word silly in there, a silly summary here where you take the empty cars data set, this one here, you've got data about different cars, you group by gear, so I've used the new syntax .by, you group by gear, so the number of gears that the car has, and then the summary function is you build a matrix that takes the 4 first values of the group and organizes them into 2 rows. So that's why you get more than 1 row. It's a bit silly. That's why I put silly underscore MPG there. But what you end up with is instead of a single row per group, you can see that you've got 2 rows per group. For example, here for 4 gears, you've got 2 rows instead of 1 because you created a matrix of 2 by 2. And he was happy with that, at least in dplyr 1. He was happy to do that and to make it a bit more flexible to do fancy things and have 2 columns, 2 rows per group in your summary. But then for dplyr 1, that has changed and they said, warning, returning more or less than 1 row per summarized group was deprecated in dplyr 1.1. They kind of backpedaled and said, well, yeah, you're right. The community kind of gave feedback and said, it's true, it's not very consistent, it's surprising, and it might lead to errors. So now we still return the same thing, right? Still works, but we give a warning and we recommend to use reframe instead. So the functionality stays there. It is useful for some people, but instead of doing it with summarize, now you do the exact same syntax, but you use reframe instead. And maybe it's a name that's a little bit more descriptive of what it does. Maybe not. But now it's separate from summarize. Now if I run this version, I've only replaced summarize with reframe. It gives me the same results and it doesn't give me any warning. So the functionality is not gone, it's just renamed, and hopefully it makes it less confusing when you get something that you didn't expect. But there's a lot more to it, even just in that version. And the last bit that I wanted to mention, maybe that's one that makes Luke happy, is that the tidyverse includes libredate by default now. So if I load the meta package tidyverse,
That's good to know.
it doesn't show me here, but it would list, well, actually I can restart my session. How do you even restart a session? Now it lists libredate as well. So tidyverse is a way to quickly get all the tidyverse packages, or at least the core of the tidyverse.
Yes, for those of you who are new, just start every single project with that line.
And you get access to dplyr, reader, forcat, stringr, ggplot2, tibble, tidyr per, but now you also get libredates, which is great for dealing with dates data. And if you're not familiar with the tidyverse, in short, dplyr is for transforming data sets, data frames, reader for importing data, forcat for dealing with categorical data or factors, stringr for dealing with text data, ggplot2 for visualization, tibble is the data structure, it's an augmented data frame, libredate for dates, tidyr for tidying, and per for iterating or programming more efficiently. And that's it for my tips. Did take 40 minutes. There is more. I stopped there because I thought that was starting to be a bit long, but some major releases still in the tidyverse. I didn't even look outside of the tidyverse over the last 2 years, where for cats, tidyr, stringr, and also a big one is HTTR2, which apparently is pronounced hitter2. In the logo, you've got the baseball thing. If you deal with APIs and getting data from servers, HTTR used to be like the package to do requests, post and get requests and all that. But it has very much aged, and they wanted to do complete overhaul of it. Header 2 is now the go-to package to do that kind of operation. Yeah, hopefully there were a few interesting bits in there. It was certainly useful for me to kind of go through what has happened over the last 2 years, familiarize myself with new things, new syntax, preferred syntax, new functions that make things easier. But I will share that on the blog, on the website, so you've got all the code there, and you can revisit that or just follow the links as well to learn a bit more. So yeah, that's it for me today. And we can move on to figuring like what kind of thing you want to work on and try and test things on your own data. Yeah.
Yeah, so I come from using Python and pandas.
Yeah.
I have lots of performance concerns when it comes to data frames. So the thing is, earlier, something I was working on, I would have lots of issues working with iteration. So let me give you a simple example. Pandas, by default, I'm getting many empty rows, for example. One column is empty. Some have data, some are empty. So empty ones are filled with NA. And if I want to take the data and feed it to some other Python thing, it is going to give me NA as a string instead of giving me an empty string. Because of type conflicts in pandas, it doesn't allow that anymore. It used to, it doesn't allow it anymore. So the thing is, this is not a vectorized operation, and you have to iterate over it. And when it comes to bigger data frames, pandas is extremely slow with this. It's really slow. It's frustrating. So what could I do about it? I know there is another library in Python called polars, yeah.
How do you spell that one?
POLARS, which is specialized for working with bigger data frames. But that's the only thing I know, and I haven't worked with it yet. So I have no idea about it. Now in R, is there something, for iteration? Maybe not operations that can be vectorized.
Yeah.
That will do it for me quickly. You mentioned something, but I didn't get you.
I guess to
extremely big data sets.
there's two things that come to mind. I've never dealt with hugely with massive data sets that actually made me reconsider what I was using. For what I do, usually dplyr is pretty happy, but I know that that's not enough for a lot of people. What I've heard is that data table, the package data table is a lot more efficient than in some cases at least. Is quicker than dplyr. So that's one option to see what data table does. If you do want to try with the tidyverse, I'd recommend looking into PUR, PURR, because usually it's quite it's designed to make things more efficient and to kind of deal with the vectorization itself without without you having to design it properly, you know?
Yeah.
So it kind of makes abstraction of the vectorization in most cases, I think. So that's one, if you go with the tidyverse, make sure you use per for that, for iteration.
Yeah.
If that's not fast enough, you can try using the data table.
Okay.
And then if you've got tables that have a lot of empty cells, it's possible that you have to look up for ways to deal with sparse matrices, because I know that there's packages and functions specialized in dealing with tables that have a lot of empty cells. I think that's what that term that you look for is sparse matrices. Yeah, or search for sparse matrix and see what functions come up that would help you with those, because I know I've never had to deal with them, but I know that they exist in some fields and they're very common in some fields, and that there's specialized functions for this kind of data. Yeah, anyone else has ideas with that, with like efficiency in large data? Maybe parallelization is also something to look into. Yeah, there was a presentation at UQRUG about parallelizing. If Jen has ideas to feel free to say. What's that? There you go. Raoul presented on that, and there's a few slides here. So free to have a look at that as well, if it's an option.
Does R have an inbuilt method to parallelize, or do you have to use something else and then
There's a
call
few.
the R function?
There's a couple.
Of options you have to choose
Okay,
from,
yeah.
you know. Yeah.
So Raoul did this presentation and he talked about, a couple of methods that it uses those two packages there for each in parallel.
Okay.
I never know what the double L is. Parallel. Which one is it?
Yeah, I would have got that wrong too.
Yeah. And double parallel. Yeah. Okay. Yeah, that's as far as I can go with it, I think.
Yeah, and what do you think about this may seem not as good, but what do you think about taking the data set into C and then trying to remove things, even though all of this is already in C?
Yeah,
But
I think that use C++ a lot. A lot of packages are rewritten into C++ to become more efficient.
yeah,
Yeah, so it might be an option if you have to go with a lower level language, if you're really hitting walls there. But there's already some options to explore. And
yeah, and by default, R is going to be much more efficient than something like pandas, right?
I wouldn't say that, no. It would be comparable, but in many ways, people find Python to be a bit quicker. Yeah. Well, I guess it depends on the task, right? Yeah, it depends on the task. I guess there would be a lot of functions that are optimized in R if it's going into specialized statistical methods, because R is a language for statistics. Whereas Python has maybe less options for specialized statistics. Then for general efficiency, I don't know. I think Python might be ahead in some ways, but again, I haven't looked into detail.
Okay, that's it. Thank you.
Yeah, cool. Thanks for the question.
Yeah, you have a roadblock.
I do, but I'm just making a smaller data set at the moment, so I'm not scrolling through 250 columns.
Who likes about running part of their code rather than running all the code? Is that you, Jan? That's definitely something you can do.
Yeah, well, do you wanna go?
And answering. Like, I think I haven't done it for a while, but like, I've had to do this in the past where I will run, I forget the shortcut keys, especially if you're using RStudio. I don't use RStudio much anymore. I'm using Visual Studio Code. But you can run sort of individual line, but it's highlighting sections of your actual script and just running that section. But if there's sort of an error at about halfway your script and you want to run everything before that error, what I find is trying to remember the shortcut. There's something like Control-Alt-B that runs everything up to where your cursor is. That can be useful as well for sort of troubleshooting errors that you're getting at certain points, where you're like, I want to get the script to work up to the line where it's broken and then debug on that line. But I do forget what the shortcut is in RStudio.
Control P.
The
Run
P,
everything
yeah.
before.
Yeah.
Or everything up to ground line.
Little B, but I might have changed it.
Now, if there's issues in your syntax, you will have the process, I guess, usually should be to go to the first error, because you might have what looks like an error, but it's caused by a previous error, right? So for example, if you've got, a parenthesis that's missing there, it might only become an error later on when you start writing some more. But I would recommend to always start at the first error and see if it solves whatever is below, because you might have cascading errors, right? There's only one issue here is that you haven't closed UQPlot here. You're missing a parenthesis, but you already have cascading errors underneath in your whole script. And you might think, oh no, what is this mess? Start from zero. Now start from the first error, try and solve that and see if it removes the following ones.
I have to run some.
Yeah, no worries. So I'll write here, start with the first error. And move to the next one.
Yeah.
But thanks, Luke. See you next time. But in a nutshell, I think what you say is that you do have, it's true for Python, it's true for R, you have to run your code from the beginning, because it's kind of a one-way street. As in, if you want to see if everything works well, and if you want to start clean and make sure that you've got your process that runs without an issue, you start from the top and run your whole script and see where it fails. First error is. No worries, Alicia. See you. Thanks for coming. I assume that was you again, but if you, hopefully that helps. To work cleanly and check that everything works. Start a new session and run the whole script from top to bottom. I think that I didn't mention before that could be useful for figuring out issues in efficiency, and that was related to what Abhishek said, but also a little bit to checking if our script works as expected. There's also profiling that might help. And that's integrated in RStudio. So has to do with the performance of your code. Doesn't mean that there's an error somewhere, but if it's taking ages, there might be something that's running in a loop and that shouldn't. To do profiling, you can go to profile and start profiling. Now, wonder if it's gonna. Maybe if I select the whole thing. Oh, that's right. And then profile select. Let's see if that works. Okay, yeah. So I selected the whole script.
It says Windows is gonna log off.
Ah, yeah, thank you.
That's right.
Thanks, Peter. So yeah, profiling will go through the whole code and measure how much time it uses for each command. And so there's, if you select the whole script, then go to profile, start profiling. It runs through everything, one by one. And then it gives you an extra tab that's called profile, where you can see all your lines and find out how much time each one has used. So this is called underneath a flame graph, and it shows you which are the most significant functions on which it's spent time. So it's not necessarily something that is in your script, as in because there's going to be functions that use other functions. So it's kind of hidden, but for example, I didn't write lapply, but it has used that function in the background. And you can see that the wider the area, the longer it has spent on those functions. And you can go through your script and scroll down and find the main culprits, right? So for example, here, main ones might be these ones. So you can see this little graph here that shows how long it has spent on something. You can also see in the data tab, it's ordered by what process has taken the most time. So here you've got the function util or the package utils actually, and read citation file that took 110 milliseconds. And if you expand that, you can see how it's broken down between 90 and 20 milliseconds. And this was really useful recently with a script that processed a pretty big data frame, not like Abhishek's data, but where I would have to wait 10 minutes for the script to finish when it shouldn't have.
I have really huge dots.
Yeah.
Sorry.
Okay. And that was excellent because I ran the whole script through it. Then I saw the bit that was taking, 5 minutes when I didn't expect it to. And then I looked at the code and I noticed that I left my data frame grouped when I didn't need it to be grouped. It didn't need to do that operation, group data. But because it was grouped, it was going through hundreds or thousands of groups rather than taking the whole data set and doing it in one go.
Yeah.
And just removing that group by that I didn't need, that was left over from an experiment, like shaved, 3 minutes from the process or something like that, something huge.
Yeah.
And that was thanks to profiling because I didn't need to go through each step and think, is this needed? Is this needed? I pointed straight away to the problematic bit. That was quite handy. So that's the profile menu. Yeah, select code, profile menu, and the vape's getting to the profile selected lines.